Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3666. Minimum operations to equalize binary string. So in this problem you are given a binary string s and an integer k. In one operation, you must choose exactly k different indices and flip each 0 to 1 and each 1 to 0. And we have to return the minimum number of operations required to make all the characters in the string equal to 1. And if it is not possible, then in that case we have to return -1. So here, let's understand this problem statement with an example here. See example number 1. So k is equal to 1 and this is your string. So here in this string, if you see, the length is 3 and k is equal to 1. So we have to choose just one index. So let's say if I choose index 2, and after choosing this index 2, let's say I flip this. So this 0 is going to become 1, and now my string s is going to look like this. And in my string s, there are all ones. So there is no 0 now. So that's it. In just one operation, I am able to make all ones in the string. So that's what we need to do here. So there is 1 0 in s. Since k is equal to 1, we can flip it directly in one operation. That's it. And here, this is good example. Example number 2. This is your string and k is equal to 3. So 0 1 0 1. So you have to choose here 3 different indices. So let's say 0 index, 1 index, 2 index, 3 index. So if you choose this and this, so now after that your string is going to look like this. So this 0 is going to become 1, this 1 is going to become 0, 0 is going to change to 1, 1 is going to change to 0, and here we choose this one, right? So this is going to become 0. So this is done. So this is first operation we did. And now again 0 1 index, 1 index, 2 index, 3 index. So again you have to choose 3 indices. So let's say you choose this and this. 3 you can choose, right? And now your new string is going to look like this 1, and here this 0 is going to become 1, this 0 is going to become 1, this 0 is going to become 1. So if you see, in just 2 operations I am going to get a string in which there are all ones, no 0. So one optimal set of operations choosing k is equal to 3 indices in each operation is this operation 1. So flip indices 0 1 3. So s is going to change into like this. Then operation 2, flip indices this 1 2 3. So s changes to this. Then thus the minimum number of operations is 2. Clear? And here if you see the constants, so s dot length is from 1 to 10 raised to power 5, very big. So definitely, let's say this is n value, s dot length is equal to n. So definitely you can't solve this problem in O of n square. You will get time limit exceed issue. So you have to solve this problem in O of n, or you can try O of n log n. And here s of I is 0 or 1, and k value is from 1 to s dot length. So these are the constants. So now let's see how you're going to solve this problem. So let's take this same example. Your s is like this: 0 1 0 1, right? So here in this string, first thing, tell me what is the length of this. Length of this is 4, and tell me the 0 count in this. 0 count, so 0 count is 1 and 2. So what I want in the end, I want my 0 count to be 0 in the end, because if my 0 count is 0, that simply means in my string there are all ones only. So this is what I need finally, 0 count to be 0. Okay, so basically I'm dealing with this 0 count. Clear this part? So as of now, zero count is equal to 2. Now here in this example, if you see k is equal to 3 given to you, k is equal to 3. So you have to choose 3 indices. So this is 0 index, let's say this is 1 index, this is 2 index, this is 3 index, right? So now here you have to choose 3. So let's say you choose this and these 3 indices. Let's say you choose this 3. Okay, so then new string is going to be like this now, 1, and here this is going to become 0, this is going to become 1, and then this is going to become 1 only. That's it, there's no change here. So here in this side, if you see, 0 count is just 1, this side. Okay, so here you are making the changes in the indices 0, 1 and 2. You are choosing these 3. K is equal to 3 now, you are choosing these 3. All right, let's say instead of this you choose these 3. Then what will happen? That simply means you are choosing this 1, 2 and 3 index now. So here you are going to get something like this, 0, 1 and 0. This is what you are going to get. Here if you see, 0 count is 3 now. 0 count is 3 here. Here 0 count is 1. Okay, let's say instead of this you choose this, this and this. So what I'm saying here, 0 index, 1 index and 3 index, these 3 you choose. So then what you are going to get here, new string 1 0 0 and here 0. This is what you are going to get. So here 0 count is equal to 3. Here there are many possibilities, right? Here you have to choose 3 index. You may choose these 3 also. So here you are choosing 0, 2 and 3. So this is also one possibility. In this, your new string is going to look like this now, 1 1 1 0. So here 0 count is equal to 1. Clear? Okay, so this is what you are doing here. So basically here if you see, let's say this is one node. Let's say this is one node, and in this node the 0 count is 2. Then from this node, let's say you go to this node, and in this node the 0 count is 1. You move to this node, the 0 count is 3. You move to this node, the 0 count is 3. You move to this node, the 0 count is 1. Then again k is equal to 3, right? Here also you have to choose any 3 in different indices, and then again you have to count the 0 count. Maybe you get some 0 count here, maybe you get some 0 count here, you may get some 0 count here. When you have to stop? When you have to stop here? Tell me, when you have to stop? You have to stop when in any particular stage you will see that your 0 count becomes equal to 0 for very first time. In that case, you have to simply stop and return the number of operations. So which type of traversal can help me here? This is a graph. This is like a graph. So I want a min cost to reach from this state, initial state, to this type of state, the min cost. So that simply means I'm talking about BFS traversal here. So this is the purpose of BFS traversal. Clear this part? Clear this part? Okay. So this is what I need to do. And here I will create, let's say, one array steps, right? So in steps, for this 0 count, which is 2 initially, so here I will just keep it 0 because initially I am here. Then from when I reach to this, here 0 count is 2, so steps and 2 is equal to 0. So you can say steps, or you can say operations to reach to this 0 count, or steps to reach to this 0 count. So initially I'm here na, so no steps, I didn't take any step, didn't do any operation, so still 0. Then after that I am moving to this, so steps to reach 0 count, which is equal to 1 this time, is nothing but I'm coming from here, from this. So until here I reach in 0 steps, and there is one more step I'm taking, so that simply means 1. Clear this part? Until here I am reaching in 0 steps, and I am taking one more step. So until here 0 steps plus 1, so this is the number of steps that I have taken to reach here, 1. Then same way from here, let's say I am seeing the 0 count equal to let's say 3. Let's say I'm seeing it 3. Okay, so steps to reach 0 count 3 is nothing but the steps that I take to reach to 0 count 1, and in this I have to add 1. So until here I'm reaching in 1 step, and one more step I'm taking, so 2, like this. Clear? This is what we have to do here. So I hope little bit you are clear what I'm doing here. So I'm not dealing with the string, I'm basically dealing with the 0 counts. Basically I'm dealing with the 0 counts. Okay, so now let me tell you a few more things which we need to take care here. All right, so let's take same example maybe, or you can take one more example. What is this? 0 1 0 1, and let's say I added few more zeros here. Okay, like this. So here let's say this is your string, and k let's say 4, or let's say 3. Let's take same. Okay, now here what is the length of this? Length of this is 7, I guess. 1 2 3 4 5 6 7. And what is the number of 0 count? 0 count is 1 2 3 4 5. 5 is 0 count. We have to make all ones right here. Okay, now here tell me one thing. Okay, so number of zeros right now, k's value is 3, right? K value is 3. So let's say uh, how many zeros you can flip? Tell me one thing, how many zeros you can flip if k is equal to 3? K is equal to 3, how many number of zeros you can flip? So you can flip uh, until k only, right? So here number of flips, it should be less than equal to k, right? At in one single step you can only choose 3 different indices na. So maybe you choose these 3, or maybe you choose these 3 positions, but number of zeros that you can flip. Okay, flip I'm taking for 0. Okay, number of zeros you can flip to 1. So it should be less than equal to k in one single step. Clear this part? I hope that this part is clear. Flips value, it should be less than equal to k. And 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 also how many numbers of zeros you can flip is also it should be less than equal to the total number of 0 counts here. Clear these two things? Clear these two things? Okay, why I'm saying that? So here you have some string like this, and k value is equal to 3. 0 count here if you see 4. So in this case, if you see only at in one single step, you can only uh, change 3 up to 3 zeros. You can change up to 3, flip up to 3 zeros only. You can't change 4. So flip is just for changing from 0 to 1. So this is what you can do. Okay, k. And I'm also saying that flips, it should be less than 0 count. Why? So let's say k is equal to 3 only. K is equal to 3 only, but I'm taking this example now, 0 0 1 1 1 1. So now k is equal to 3, and 0 count is equal to, in this case, 2. So now again if you see, number of zeros you can flip to 1 is only 2 now, because only 2 are available, even though k is equal to 3. even though you are choosing 3 positions, but only 2 zeros you can flip, right? So I can say max number of zeros that you can flip is going to be the minimum of math dot min of k comma 0 count, or you can say current zeros. Okay, current zeros or 0 count, right? This part, I hope that this thing is clear. Okay, this is done. Keep it in mind, this part. So max number of zeros you can flip, it should is equal to math dot min of k and 0 count, right? So just keep this thing in mind. Okay, so let's say this is your equation 1. Let's say this is your equation 1. All right, now how many minimum number of zeros? This is the max number of zeros you can flip. We have to find out the minimum number of zeros you can flip. Okay, so how we are going to do that? All right, so let's see that. Okay, so here, if 0 count is 5 here in this example, if 0 count is equal to 5, then what is the count of 1? Count of ones. Count of ones is going to be nothing but length minus 0 count, or current zeros. 0 count, you can say 0 count, or you can say current zeros. Okay, or you can say ZC, whatever you want. Okay, so that's what I'm doing here. Sometimes I'm saying 0 count, ZC I'm writing, or current zeros, same thing. Okay, so this is nothing but the number of ones. Okay, so here length minus current zeros or 0 count or ZC. Okay, just for short form I'm writing current 0 count. Okay, so this is nothing but the number of ones you have. Number of ones. Okay, so 0 count I am representing with this ZC, and number of ones is going to be the length minus this 0 count. And here how many number of ones I have flipped. So if that is going to be nothing but, here if you see this equation. Okay, so flips, I'm saying the process of converting from 0 to 1, right? So if in total we are changing k positions, we are changing total k different indices, in which 0 in which we have to take care of these two things, na, 0 to 1 and 1 to 0, for k different positions, right? So here if let's say we are doing the flips for 0 to 1, this is nothing but flips. So this part I can say this is nothing but overall total is k minus flips is for 1 to 0, k minus flips is for 1 to 0 conversion. Clear this part? 0 to 1 is I'm saying flips, so 1 to 0 I will say k minus flips. So here the total number of ones, okay, total number of ones I am flipping, k minus number of flips, k minus flips, right? So this value, okay, this value is always going to be less than equal to the length minus this number of ones. Okay, this is nothing but number of ones, number of ones, right? So what I'm saying, the number of ones that I am flipping, number of ones that I am flipping, that is nothing but k minus flips. This value is always going to be less than or equal to the total number of ones that I have in my string as of now. This is what I'm writing. Okay, this is what I'm writing here. Clear this part, right? And now I can further shuffle this equation. I can further rearrange this equation, and it is going to become like this. Flips, okay, flips goes here this side, okay, flips goes here, and everything else comes here. So flips is going to be greater than equal to, and now this time k, and this comes here, so k minus length minus 0 count. Clear this part? I can write this equation like this. And definitely the flips value, right? Here I am doing k minus of length minus 0 count. Okay, so this value, I don't want my number of flips to be negative. Okay, I don't want this, right? So you can do one thing now here. Instead of this, you can further write it like this: number of flips, it should be greater than, it should be bigger than, it should be bigger than 0, and here k minus length minus 0 count. Here you can say math dot max of. Okay, so because this k minus length minus this 0 count na, this value can go actually negative. This value can go negative. So that's the purpose here. Okay, because here if you further simplify it na, it is going to look like this: k minus plus length plus 0 count. Okay, so let's say some example like this na, a length, let's say 5, and here if you see, let's say I want to show that why this 0 is important. Okay, so I want this value to be negative. Right, so here what I will do, length is 5 plus 0 count is just 1, and here your k value, let's say you can say 2. Okay, so 2. So in this case if you see, 2 minus 5 is minus 3 plus 1, so minus 2. So can you do minus 2 number of flips? Flips should be some positive na, right? So that is why, that is the reason I'm taking this 0 comma k minus length minus this. Okay, to be, that's why I'm taking 0. Okay, so let's say this is nothing but your equation 2. Okay, equation 2. So now here just check these two, equation 1 and equation 2. Okay, so this flips, okay, this is a flips I'm calculating now. So here I'm just writing a flips. Okay, let's say flips only. So flips is nothing but math dot min of this k and jc. Okay, so flip value. Okay, so here if you see flip value, okay, I'm just placing this flips here, and now here what I will do. Okay, so here if you see this flips value, so this side it is bigger now, so right, and here I have to write like this: math dot max of, and here I have to write 0 comma k minus length minus 0 count. Okay, so this is correct na, flips is bigger than or equal to, okay, flips is bigger than this, right? Same way here also, less than equal to, if you see here the flips value, okay, is less than or equal to, you can say this is a max flip na, max number of flips, max number of flips. Okay, so math dot min of k comma zc. So here less than equal to, you can say math dot min of k comma zc, right? This is what I'm writing. So actually this is nothing but a range. Okay, so I am giving the name of this as, let's say, max flip, max flip, and let's say I'm giving the name of this thing as min flip. So this is nothing but a flips range. Okay, flips range is going to be in between this min flip to max flip, and this flip is nothing but it's showing the number of zeros. I can change it to 1. Okay, so I hope that this part is clear. Okay, this part is clear, right? So max number of zeros I can change over, and the min flips and max flip is just giving the range. Okay, number of zeros I can change it to 1. Okay, number of zeros I can flip to 1. So this is the range that I'm getting here, right? So this is what we are doing here, right? So this k minus flips is nothing but number of ones that I'm flipping. So this is the format that I have derived, right? K minus flips. So flip, originally flip is nothing but the number of zeros only it's showing. So flips range I'm calculating, right? So I hope that this part is clear. Here I'm taking flips, and flips is nothing but 0 to 1. So for k I have to do, okay, that part I have explained here now. 0 to 1 is for flips, so 1 to 0 is for k minus flips. Okay, so in this way I calculate the flips range, and here you already know that why I'm writing it like this, k comma 0 count. Okay, so I have explained this with an example here, right? So that's nothing but max number of flips, and here this is nothing but minimum number of flips that we can do. Okay, so that is the formula for this one, right? Okay, clear this part, right? So actually these two things I will use in my code also, right? Let me just minimize the screen. So these are the two formulas. All right, okay, so this is done, right? Now here at one node we have some number of zeros, at another node also we have some number of zeros. Okay, so let's say here we have z number of zeros, and here we let's say we have uz updated number of zeros in this. So now I want to write one formula to calculate this, actually how you are going to calculate this. Okay, so here tell me, let's take this example 0101. Okay, so here okay, so here if you see in this case the zero count is equal to 2, and the length is equal to 4, and let's say k value is equal to 3, right? Okay, now here flips is for the conversion from 0 to 1, right? This is what we know. Okay, so now let's say I am choosing this and this as my k, different three indices. Okay, so then after that I'm going to get something like this. Okay, this is what I'm going to get after that, right? But now here in the flip part, in the flip part, in if you see this flip part, so total two zeros I have in the flip part, total two zeros I have. Okay, in the flip part I have two zeros, and how many number of ones we have here? Number of ones that I have here is in this different indices that I've chosen, in this we have just one. Okay, but now when I'm doing the flip, okay, when I'm doing the flip of this part, so these are becoming 1 and this is becoming 0. So 1 0 I'm adding, and that 0 is coming from here, and here I'm removing it. Okay, so if I am saying that this is my z initially, and then this is going to be my uz, okay, updated number of zeros. So updated number of zeros is 1 in this state. Okay, but I have to derive one formula, okay, how to calculate that. All right, in this part, so I have flipped two zeros, right? I have flipped two zeros to 1, and 1 to this 0, so 1 this part. Okay, so I can say that the updated number of zeros that I will have is nothing but the overall number of zeros in this, overall number of zeros in this, and from this how many number of zeros actually I have flipped. So I am going to say f, right? So here I reduce that frequency. Okay, so let's say if I have something like this na, a string, my string is like this 0101, and I added a few more. Okay, so let's say if I'm choosing this part, okay, for flipping, so only two zeros I'm flipping na, but in total I have all these zeros. So here z minus f, so this is the count that I'm removing. Okay, so these two count I'm removing, okay, in the updated zeros. But in this updated zeros count I have to add the count of this one. So this count is nothing but, I can say, this total length of this, okay, or total count of this is nothing but k, and among this k minus how many number of different indices where I am not doing the, where I don't have the 0 to 1 rule, but we have 1 to 0. So 1 to 0 rule simply means k minus f na. K minus f, this you already know here. K minus f rule. uh, Here k minus flips this rule, right? So because here 1 are changing to 0 in the your updated zeros, so this is a formula that I have to use here. Z minus z plus k minus 2f, you can write it like this. So just keep this formula in mind, okay? And I can prove this na. I can prove this. So here if you see this particular example only, right, here updated number of zeros. So if I flip this na, so after that I will get this 101, and here 1 0 0 0, okay? So here if you see number of zeros is 1 2 3 4 5, and here if you see the number of zeros 1 2 3 4. Okay, so here I can prove this, right? Here z initially it is 5, 5 plus k value is 3, I am taking 3 minus 2 into f. So f is nothing but, so two zeros I am taking into, cause changing it to 1, okay? Two zeros, 2 times I am doing the flip for 0 to 1, okay? So here 2 into 2, so here what is you are going to get? 5 plus 3 is 8 minus 4, that is nothing but 4. That's it. So this is the formula that I have derived here, okay? So basically you are dealing with only these few stuff, okay? These two, this formula and this formula, okay? So let's take some example, okay? So let's try solving this example only, right? So here I will show you. So just I will just give you a quick recap, okay? What you need to do now: 1 0 1 0 0 0, okay? I will not take much time here. So here this is what you have initially, string. So basically you are just dealing with the zero count. So zero count zero, whatever you want to say, okay? 1 2 3 4 5. And what is the length of here string 7, and let's say k value is equal to 3. All right, so now here you have different choices now. Different choices actually you have, right? Okay, but what are the different choices you can have here? Okay, so that we can calculate, okay? That we can calculate using what? Using the formula of the flips range, okay? So flip range. So here I told you that this range is from, okay, number of zeros that you can flip is from, here you have to take the math dot max of 0 comma, and what is here 0 comma k minus length minus 0 count, k minus length minus 0 count, okay? This is the formula. 0 count or current zeros, right? And here this side formula is nothing but math dot min of k comma current number of zeros, okay? 0 count, whatever you want to say, 0 count zc, right? So this is the formula, okay? So now using this formula, it is very easy for me to calculate the number of flips, okay? So just apply this same thing in the formula la. So here math dot max of 0 comma k is 3, 3 minus, what is the length? Length is 7 minus 0 count is 5, right? So 0 comma 3 minus 2, 0 comma 1. So here I'm getting 1, okay? I'm getting 1. So number of flips, okay, that you need to take, the range 1, it should be greater than 1, okay, or equal to 1, less than, here math dot mean of k comma 0 count, so 3 and 0 count is 5, so 3. So this is the number of zeros I can have, okay, in the indices that I can take, okay? So I can have 1, I can flip just one time, okay? 1 0 to 1, okay? Or I can maybe take 2, or I can take 3, okay? These three things I can take, right? Right? So it means that k is equal to 3 different indices I'm choosing. So in this side I'm taking those parts where I'm choosing 2 zeros as indices, okay? So here we, let's say in this side, let's say I choose this and this only, okay? Only one time I'm flipping from 0 to 1. And here I am taking the scenarios where I can choose this 0 0 and 1, or I can choose 0 0 1 0, or I can choose 0 1 0, or I can choose 0 1 this 0, or I can choose 0 1 this 0. Okay, but this is a normal scenario, right? So flip 2 means 0 to 1, 0 to 1 conversion, and then 1 1 to 0. Okay, this is the case I'm taking here. Means 0 to 1, and the rest all I'm taking like this, 1 to 0 and 1 to 0. Here simply means I'm taking this case only, 0 to 0. All are changing, from 0 to 1, 0 to 1, 0 to 1. So here actually, if you notice here one thing, here actually I'm just dealing with the, I just need to know about the zero count. I don't need to take care of this string. If I just know the zero count now here from this, then I can derive these three states from here. Okay, flip 1, flip 2, flip 3. Okay, done this part. Okay, now here, again I'm not going to write this new string. Okay, here I'm not going to write this new string. So here, if you want, you can remove it. I'm taking zero count only. Here I'm going to write what? Updated zero counts. Here I'm going to write updated zero counts, and here I'm going to write updated zero counts. And updated zero count also very easy to calculate. Formula you already know to calculate the number of zeros. This formula, z plus k minus 2f, z plus k minus 2f. This is the formula. So apply this formula. So zero count from above 5, 5 plus 3 is 8, 8 minus 2 into 2, that is nothing but 4. 4 is the updated zero count you are getting. Okay, updated zero count you are getting 4 na. Formula apply na here, 5 plus 3 minus 2 into 2, so 8 minus 4. Okay, same way here apply the formula, 5 5 plus 3 minus 2 into 3, so 8 minus 6, so here 2, updated zero count is 2 here this time. Okay, and here the updated zero count is going to be z is 5, k is 3 minus 2 into 1, so here 8 minus 2 is 6, so updated zero count is nothing but 6 here this time. Okay, so now from this updated zero count 6, again you have to again find out the range. Okay, number of zero flips that you can do. Okay, again here you have to define this range, number of flips you can do, number of flips you can do. Then again here you are going to calculate the updated zero count, updated zero count, updated zero count. Okay, in this level also. Okay, but for very first time, okay, when you are going to get calculate the updated zero count equal to 0, when you are going to get that, you have to stop. Okay, and you have to just return the number of operations. So here number of operations to, or number of steps to reach to this zero count is 0 initially. Then from here to here we are moving, so I will just update that here what are the number of steps that I'm taking. So I have to just do the number of steps to reach here plus 1, I'm reaching here. Number of steps to reach here plus 1 is going to be this state. Okay, these states. So like this I will iterate, right? So this is what we need to do, right? Clear this part? Okay, so let's write the code. Okay, and let's understand side by side what I'm doing here. So going to be very easy, not difficult. All right, but we have to see if we can further optimize it. Okay, but we will use the same code only. So int length is nothing but s dot length. You are calculating the length first, and then you have to count the initial number of zeros. Count initial number of zeros. So int zero count is equal to 0, and then for int I is equal to 0, I is less than length, and here I plus plus, and here if s dot char at index I is equal to 0, then in that case you have to update the zero count. So here just calculating the zero counts now. And one very simple basic case now, if it already has no zeros, then no operation needed, right? So if zero count initially itself is equal to 0, then just simply return 0, no operations required. Okay, now here we have to calculate the number of steps we are doing or number of operations we are doing, right, to reach a zero count. So here I will create one distance array for BFS, minimum operations, yeah, steps to reach a zero count. So here what you need to do, int steps, and here new int, here you have to write length plus 1, clear this part, and here arrays dot fill. So here you have to just simply write steps comma -1. So until now we are just making everything to -1. Okay, so in all these zero count, okay, number of zero counts, so we can have how many number of zero counts? Okay, so here if you see this, maybe this example, so we can have of length 4 na, length is 4, so we can have zero number of zeros, we can have one number of zeros, we can have two number of zeros, we can three number of zeros, we can have four number of zeros. So that is why I'm taking n plus 1, length plus 1, if you notice here. Okay, that is the reason. Number of steps. So here number of steps to reach zero number of zeros, number of steps to reach one number of zero, number of steps to reach 2 as zero count, number of steps to reach 3 as zero count, number of steps to reach 4 as zero count, right? So here initially I'm saying everything is -1, but by default the very first case, we when in this stage we have two zeros, right? So initially we are at this stage where we already see the 2 as zero count. Okay, so here it should be 0, this value, right? So here I will say steps 0 count is equal to 0, done. Then simple story you have to write here, whatever we used to do in the queue, right, in the past also. So here it is very simple na, integer BFS I'm applying now, integer, then here q or q, okay, and here you can say new linked list, done. This is done. Now here, okay, or you can, if you want to, just know that this is BFS queue. Okay, BFS, just a name, you can give it q or also, but I'm applying BFS. Okay, that's what I meant to say here. So here in the BFS queue, copy this. So first what you need to do, you have to offer the zero count. So I told you that it doesn't matter what is the string you have. Okay, initially it doesn't matter whatever the string you have. Okay, what matters is the zero counts. Okay, so zero count, so zero count is 5, then I'm checking the different other states in which we have different zero counts here. Okay, right. So and one more thing, okay, maybe after some time I will say that. Okay, but just if you notice one thing, here zero count is 5 odd, so here we are just getting the even number of zero counts. Okay, because of this formula na, z plus k minus 2f. So just keep this simple thing in mind as of now. I will not use this in code as of now, but later on, right? So here this what you have added here. Okay, and here BFS, in which BFS you have added this zero count. All right, Now after that, what you need to do? Okay, so here we have already updated the steps of zero count is equal to 0 initially, right? This is already done. Right now after that, here you have to simply write while your BFS queue is not empty, na, is empty, is empty, is not empty, right? So in this case, what you do, you first poll the current zeros. Okay, so current zero, whatever you have in the queue, okay, you have to poll that topmost. So here BFS queue dot poll, right? So you poll this. All right, now after that, what you need to do? So now we choose the flip zeros. Okay, so here you can add the comment. Maybe you have to do what here, you have to flip the zeros. Okay, so let's say we choose flip zeros. You can say flip zeros among k selected characters, right? So flip zero is nothing but 0 to 1 conversion, right? Let me just format it. Okay, now here valid range we have already calculated using the formulas, right? Valid range ensures we don't pick more zeros than available, right? So here if you see how smartly our formula make sure that here in this case that number of zeros that I can flip to 1 is always going to be in this range only, 1 to 3, because here if you choose, you can choose any pairing. Okay, for k is equal to 3 now, you can choose any three indexes. You will always find in those three different indices, you will always find maybe one number of zero, maybe two number of zero, and maybe three number of zeros, but you will never find zero number of zeros in that, four number of zeros in that, five number of zeros in that, six number of zeros, seven number of zeros. Okay, so see how smartly our formula plays here, this formula that we have derived. Okay, so valid range ensures we don't pick more zeros than available, and don't exceed, and you can say and don't exceed string limits. Clear this part? So here formula that we have written, right? Mean flip is nothing but, I told you, math dot max, because flips can never be negative, right? So that's why I'm taking here 0, and this you already know, k minus k. K is the total window size, and in this window size I'm subtracting what, minus length, number of one flips na, length minus current zeros, length minus current zeros, right? So this is the mean flip value, and this is your max flip value. So how many max flip you can do that? So overall, current zeros is overall, right? Overall. Okay, and here math dot min is nothing but here k minus current zeros. So current zeros, that's it. This is what you need to do here. Then after that, here you have to simply apply the formula, loop, run the loop, int flip zeros, and flip zeros is starting from this min flip, and this flip zeros, it should be less than equal to the max flip, and this flip zeros here you have to increment it, flip zeros plus plus, that's it. And updated zeros formula you already know, so here int updated zeros formula is nothing but the current zeros you have, and you have to add k to it, and minus 2 into the flip zeros, 2 into flip zeros. So if you see here, this is what we are doing here na, z plus k minus current zeros plus k minus 2 into flip zeros. So that's why I'm getting this, right? So this is what we are doing every time, right? And here inside this few things we will check now. If we have to update the steps as well, right? The operations or steps. So if steps and here updated zeros, this if steps of updated zeros, right? If it is equal to -1, right? If it is equal to -1, so in that case only we have to update. So very first time when I see this state in which I have this my number of updated zeros, so it's nothing but the steps of, it's coming from what, it's coming from updated zeros, this step, okay? This state is coming from this state in which we have current zeros, not updated zero counts but current zero counts, right? So here I will say steps of current zeros, and in this I have to add +1. That's it. Clear this part? And here few more thing. If your operated zero, okay, if operated zero, if it becomes equal to 0, then in that case you have to simply return from here na, return what, the steps to reach to this state, operated zeros, right? And every time what you need to do, if we still didn't reach here, so in the BFS, okay, in the BFS you have to offer a new state na, BFS, and here offer updated zero state, updated zero state. This is what you are updating. And in the end, if we still didn't return anything here, then here you have to simply return -1 if it is impossible to make all the characters 1. That's it. This is your code. Let's run it. So let's fix this. So line number 31 only it is saying. So let's fix this. So use semicolon here. Let's run it again. All right, there is one more issue. Line number 7 it is saying. So here, yeah, this s should be small. Let's fix it and again run it. So see, all the test cases has been passed here, but will be able to submit the code or not? Let's see. Or we'll get time limit exit type issue. See, we are getting time limit exit issue, but just for 5 test cases. 994 test cases passed out of 999. So we have to fix this. All right. Now how I'm going to fix that? Now we have to optimize the code. So that's the next thing we have to do here, right? Okay. So let's see the optimization process now. So this same code only I'm going to add a few more details in it and we will optimize it. Okay. No change in this code, right? Okay. Let's see the optimization process now. Here, this thing, if you see zero count is equal to 5, and in the next states, if you see zero counts, operated zero counts, we are getting 2, 4 and 6 odd value, and here we are getting even values only, and here 2, 4 and 6, right? Okay. So here one thing, why we are getting even, because of this formula, the way we have written here. So z plus k is going to remain same, and here we are just going to subtract the double of this 2f. Okay, so 5 plus 3 is 8. This is going to give me 8, and here we are subtracting the even, 2 into 3 6. So here I will get some values, right? So here it's not like this only. So here if you see this example, uh, 0 1 0 1, right? So here number of zero count is equal to 2. So now here let's say length is 4 and your k value is equal to 3. Okay, so again you apply the formula, so this is your string na, 0 1 0 1, this is string. So instead of this na, I told you this is nothing but one state of zero count. 0 count state equal to 2 here of this, right? So now here if you apply the formula, so what is that formula? Formula is simple na, 0 comma here k minus length minus current number of zeros. This is the formula. Range, right? So math dot max of this number of flips that you can do, it should be less than equal to math dot min of k comma current number of zeros. This is a formula, right? So here if you apply this formula, so 0 comma k is 3 minus 4 minus 2, so you are going to get 0 3 minus 2 is 0 1. So max you have to take, so 1 is less than equal to flips and is less than equal to math dot max of k comma cz, k comma cz 0 count 2 3, okay, so 2, so this is nothing but 1 to 2, okay, these are number of flips you can do, right? So 1 or 2 at most, right? Flips is for 0 to 1, flips is for 0 to 1, okay. So now here in this case what you will find, the updated 0 count. So updated 0 count in this case, updated 0 count, so you will find the updated 0 count as nothing but simple. What is the formula for updated 0 count? That I have explained in the last step, okay. So that is nothing but current number of zeros 0 count plus k minus 2 into f. So 0 count is nothing but 2 plus k is 3 minus 2 into f. 2 into f is first time 1, let's say, so 5 minus 2 is 3. Here next time is 5 minus 2 into 2 is 1. So here you are getting this 3 1. So here also if you see, if it is even, so here you are seeing the odd values, odd values. This is same, okay, z c plus k, but here 2 minus 1, 2 into 1 you are doing, so always you are going to get in this, okay, and 1 gap. So here you will see all odd values, right? You can check maybe for other scenarios as well, all odd values. And if here you have even, right, same way here if you have odd, here you will see all the even values in that case. Clear this part? Okay, so now here you will also find one more similarity here. Here actually if you see, we have min is this and max is this. So inside this, 1 is this and this max, okay. So 1 to 2 it is saying the range, so we have only two values. So here we know 1, here we know 3, that's it, okay. But here if you see, it is saying in this example, if you see, it is saying 1 to 3, 1 to 3. So if for one flip 1, if you see just one flip, then you are getting the updated 0 count value is 6. And if you take the max value only, I'm not taking the in between values, I'm taking the max value only. So f is equal to 3 flips if you are doing, then you are going to get 2. So if you know these two values now, if you know these two values, so in between you can easily fill out the values, right? Here we have 2, so that here we have 2 and here we have 6. That simply means it is starting from even and ending at even. So in between we have only 4 now, so 4 is the what we are going to get for this flip is equal to 2. I don't need to calculate the formula and write it, okay. I can simply write it, okay. So say here like if I have a one string of length 7, let's say length 7, I have one string, okay. So here we can have zero number of zeros, zero count maybe 0, maybe zero count is equal to 1, zero count maybe equal to 2, right? So all these are possibilities na, 0 1 2 3 4 5 6 and 7, right? These are all the different possibilities, zero counts, different states I can get, right? So now it is very easy now, like if I know that this is a beginning and this is the end, so in between I need to pick this and then this will come, that's it. So if I know this and I know the max, in between I just simply need to pick all the values, because
In some cases this value may be very bigger na. Here we are getting the range like this only, 1 to 3 small, but this number of flips can be like this na, 1 to 1000. So are you going to calculate for all the flips one by one all this stuff? No, you can do simplify that thing, right? Maybe you can create one set, and in the set, let's say this is some set, in that set you add the number of different operated zero counts. So you can have only these many zero counts, okay, for the string of length 7, right? So if you know the min and if you know the max, so in between, if it is a even, you have to pick the even ones. If it is a odd, then you have to pick odd ones, right? Okay, this is one little bit optimization we can try, right? Or for more basic thing, okay, for more simplicity, instead of this you can maybe try to create one even set or odd set also. Even set, so even set you can add maybe 0 2 4 6 like this, and in odd set you can add something like this, maybe 1 3 5 7. So now you can 2 to 6, you know, right? So you can just check like this now, that's it. In the odd set you can, if you range is 1 to 7, so you can check like this now, 1 3 5 7. These are the new updated zero count states. Directly you can get the states, right? Little bit optimization I'm doing here. Okay, and here if you see these operated zero counts, right? Here zero count is coming as 5, here it is coming as 6, here it is coming as 4, here it is coming as 2. So zero count is not always actually reducing. Sometimes it is, we are seeing 6, sometimes we are seeing 4, sometimes it is this is 5. In the next step may see smaller value, may see bigger value, right? But here one case, here let's say I'm saying the zero count is equal to 6, and here let's say I'm seeing the zero count as let's say 4. Here let's say I'm saying the zero count as here let's say 5, so here 6, let's say here I'm saying the zero count equal to 2. Then here again, here let's say I further solve it, again I further solve it, again I further solve it. There may be some case, let's say here I'm seeing the zero count equal to maybe 5, okay, maybe. And here also let's say maybe I'm seeing the zero count maybe 5, okay. I'm just taking one example, okay. You can check the updated zero count states, but I'm just saying, okay, let's say it is 5. So here you have seen the zero count 5, here again you are seeing this same state, here again you are seeing this same state. Very first time I have seen this state here na, why I need to again start from here? I don't need to solve it, I don't need to check this state now, because I am trying to solve this state here. I may have solved this state already here, okay. Let's say here I'm getting zero count equal to 1, here I'm getting zero count equal to 1. So if here I have solved zero count state 1, then why I need to solve it here? That also I need to remove, okay. That also I don't need to process now, right? So here let's say maybe I have a process state 2, process state 3, process state 4, okay, in the past. Now there is scenario 1 to 7. So 1 to 7 means I have to pick this one, and then I will say 3 is not there. Then 5, let's pick 5 and then pick 7, okay, like this, right? Okay, and here like this. But you are not planning to actually use this, okay, because you can do one thing na, even set odd set. If you have already seen the state, let's say 3 and 5 you have seen in the past, let's say, so you simply remove it na, remove it from here, remove it from here, from odd set. Just remove this, this is a set na, remove it, okay. This is what you can do for simplicity. So now I don't need to do a lookup here one by one, okay, that whether it is already used. I will simply calculate, I will search a lower bound or upper bound, okay, where the values may start. Like if in odd set maybe I'm searching from 1 to 7, so I'm going to start from here. But if I'm searching from let's say 7 to 13, then I can simply check the first value which is equal to this 7, or greater than 7. So I will find it and then I will start searching. Okay, like this. So these are a little bit optimizations we need to do in our code. Okay, so let's do those optimizations. There will be no big change actually in the code. So here length you are calculating, zero count here you are taking, and this it will remain same, and here's the steps, it will remain same. Okay, steps of zero count is 0, and then q you are taking, so it is also going to remain same only. Okay, then after that what you need to do here? Okay, but first we have to implement this even set and odd set now. So what I am doing here, trying to do here, let's here separate unvisited states, unvisited states by parity. So here tree set you are taking, okay, and it's an order only, right? Tree set integer, and here you can say even counts new tree set, and here same before odd count you can write it. Let's say this is odd count, odd counts this. Okay, and then after that here run one loop actually for int, we have to add the values in the even counts. Okay, so int count is equal to 0, and this value, okay, count value, it should be less than equal to the length, okay, count of number of zeros, and here count plus plus. So here you have to write if it is odd. So if it is a odd, so count and 1. Okay, let's say first it is if it is a even. Okay, count, then in that case the count and 1 value. Okay, you are doing the and with 1. So if this value, okay, count add 1, so if it is a even, okay, so this value is going to come out to be 0, right? So in that case even counts dot add, and here you have to add the value of count. That's it. And else if count and 1 value is equal to 1 only, that's it means it's an odd number. So in that case you have to increment this odd counts, odd counts dot add equal to 1. Then here you are taking the BFS, then BFS you are offering this, and there here you are taking this. Okay, no change until here. That's it. Okay, only I'm adding this basic things, right? Now here I will fix few things, right? So current 0, same thing here. So now we are not going to do this. Okay, we are not going to do this. Okay, not do this. Okay, not doing this. We are not doing this. Not doing this. Not doing this. Not doing this. Okay, what we are going to do now here? New plan. New plan is like this. Instead of iterating over all possible flips, directly compute the reachable range of the new 0 counts. And I told you that you will find out like this only. So here if it is 2, so here 1 and 3 odd values. Okay, here if it is odd, then you will find even value. So 2 to 6 you know, so in between you have to fill 4. If you know 2 to 12, so in between you will have 4, 6, 8, 10, 12, like that. Okay, so this is a plan now, right? Okay, now we have to choose the correct parity set. So here I'm not going to delete anything as of now. So here just going to add one comment, choose correct parity set. Which set you need to choose, it all depend upon the what, it depend on the what is the current state now. So here what you have to do, tree set okay, and integer reset integer, and this is a target set. So target set parity. Okay, so here what you will do here, min reach, min reach. Okay, so here what I will do here. Okay, so min reach and max reach we have to calculate. So instead of this, here we are just calculating the min flip and max flip na. Now see how I'm going to utilize these things. Okay, so these two. So here I will create two variables. One is, let's say, int min reach. Copy this, int min, and here reach, int min reach, and here int min reach, and here I want to find the max reach. Okay, instead of just calculating the min flip and max flip and then iterating over all these flip zeros to calculate the updated zeros, I will calculate this directly. Okay, min reach and max reach of the updated zeros. So formula is going to be same, so this part is going to be remain same, right, in min reach and in max reach. Now here if you see one more thing, interesting thing, that here if this flip size is smaller, you are getting bigger value. If it is bigger, you are getting smaller value here. Same way here, if you see smaller flip just one, so updated zero count is bigger. Okay, so for smaller you are getting bigger, okay, values. So here with max reach you are going to get with the min flip. So here what I will do, I will just copy this and paste it here. That's it. 2 into, that's it. Okay, same way this I will multiply here, 2 into this, that's it. Okay, this is what I'm doing here. So this is how I will get this, and I will just update, remove this. And now how I'm going to choose the correct parity set. So this is nothing but uh, if min reach modulus with the 2, okay, if it is even, if it is even, then you have to go where, you have to go to this, if it is even, you have to go to the even count set na, even count reset. Okay, you make a jump to even count set. Otherwise you have to go to the odd counts, odd counts. Clear this part? Easy. Now here candidates. Okay, what are the candidates I am going to choose? So here you can write integer candidate is equal to, so target set, I go to target set, and I'm going to take the first value. Okay, seeding first value from where I can start, which is equal to this min reach or greater than this min reach, very first element in my target set, which is greater than equal to min reach. I will just pick that. So this is my candidate. Now this part I'm not doing now, this part I'm not doing, I can remove this part I'm not doing. I can remove this, right? So here now see this, now I get the candidate. Now I have to just check these candidates now. So while the candidate is not equal to null, and candidate is less than equal to max reach. Very simple as of now. So in that case only what you need to do, so int next 0 or updated 0, you are going to get some state now here. So next 0 is going to become the next 0 is going to become a state, a new state. So candidate, right? Now here steps to reach to this next 0 is going to be equal to steps to reach to the current zeros plus 1. That is very simple. They are in order, we already know, right? They are in order. Okay, so from this to this, right? So that's what I'm doing here. And here if same thing that I've written in the previous code, if next 0, if it becomes equal to 0, then in that case you have to return what? You have to return this steps of next 0. Clear? And here in the BFS you have to offer this what? The next zeros. Okay, the new candidate, the new state, and target. Since we have already checked this uh set, okay, target set, we have to remove this. Okay, we have to remove this candidate now. We have already checked this candidate now, so this is done. That's the benefit here. And then your candidate is going to be the target set dot ceiling min reach. This is your new target. Okay, this is your new target, and that's it. This is what you have to do here. You can remove this stuff, and let's run it and see if the code will try to fix that. So yes, there are some issues, so let's fix that. So minus k into 2 into math.min of this, and I think this is missing here. Let's run it again. Okay, here also I think same thing. One more we need. Let's run it again. So see, that's it. So all the test cases has been passed. Now let's see if we are able to pass this solution or not for all the test cases. So there is some issue, so let's try to fix that. Okay, let's see where we are getting this issue. Okay, so here we are missing one thing. Okay, here we are missing one thing, right? So we have to remove the starting state from the available pool, right? Starting state we have to remove, right? So here you can write maybe one more line. If here 0 count initially and 1. Okay, so if starting state, okay, so if this is even, so from even counts you have to remove this, na? Even counts dot remove this 0 count. Okay, this we forgot to add. Else from odd counts you have to remove this. So let's paste it here. Let's run it again. Now let's submit it. So see, now our solution is up, right? That's it. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.